Hey, today we're going to talk about 4.3, soil composition and properties. So take a moment, review the enduring understanding, check out the learning objective, and pause the video, review the essential knowledge, and set up your Cornell notes. So we will be discussing soil composition, and we have three different particles that make up the soil. We have sand, which is the largest. Sand, like a grain of sand you would see at the beach. And this is the relative size. So I'm not going to be able to show them all on here relative to one another. So if sand would be that big, and that's just the tip of it, silt is this size, and clay is incredibly small. So sand is the largest, and it is really small from our perspective. Just imagine how much smaller silt and clay would be. Clay is almost like a dust particle. It is so small. Clay particles typically, or they will have negative charges, so they will be attracting water molecules because the hydrogen atoms in the water molecule have a slightly positive charge because of their polarity. And they will also attract nutrients like calcium, magnesium, and potassium. And these are nutrients that are necessary for a plant. And when we're talking about these nutrients are called cations. Cation is just a fancy way of saying a positive ion. So we talk about soil in terms of cation exchange capacity. So the cation exchange capacity is something that's very important. We want a good cation exchange capacity, so we have these nutrients that are available to the plants. So we have soil sample A, soil sample B. Soil sample A could be mainly silt, I would say. Soil sample B could be exclusively sand. And when we're talking about porosity and permeability, porosity is the measure of the open space. So we actually have more particles in A, but we don't care about the particles. We care about the spaces between the particles. And we have more porosity or more pores in sample B. Now permeability measures the flow of the water. So sample A, it would not flow as readily because it would keep bumping into these particles. So water is going to flow more readily in sample B. So sample B would have higher porosity, and because of that porosity, will have better permeability. So when we determine soil texture, we're going to do this in class, but what you do is you take a sample of soil, add it to water, shake it up, get it to look all muddy, and then let it settle. Now you can do this on with regular soil, and it might take upwards of a week because the sand is going to settle out relatively fast. The silt will maybe take about a day, but the clay, or silt might take a couple hours. The clay is going to take a few days at the least. It might take up to a week, or even after a week or two, there might still be clay that's suspended. Because it is so small, it takes a long time for it to settle. You can also add chemicals in there that will, in essence, like cause it to settle out faster, and that's what we're going to do. When it settles out, you want to take the total height of this, and what you want to do is use this generic formula. The percent over 100 equals part over whole. So the part is going to be which component you're talking about, and the whole is going to be the whole height. So we have 8 plus 8 plus 4, that is 16 plus 4, that is 20 centimeters. It doesn't matter if you're using a graduated cylinder, you can use anything. You just want to use something that's pretty much parallel. The sides are parallel, it's pretty perpendicular. It's going to be slightly rounded. It's not perfect, but you don't really want to use a round, like a fishbowl, for example. You want to use something that's going to be pretty much parallel. Now, with this, when we do this calculation, we have x over 100, which we want to figure out the percent of the clay. So we formulate a proportion, 4 over 20, and that is 20%. So just keep that in mind. We have 20% of this is clay. Now let's do the same thing for silt. Obviously, 8 is twice as big as 4, so I bet you can already predict what this is going to be. But let's plug in the numbers. Percent over 100 equals the part over the whole, the silt component over the entire soil component. 8 over 20 is 40%. And finally, the sand component, same exact formula, x over 100 equals 8 over 20. That is 40%. Now we're going to remember these percentages: 20 for clay, 40 for silt, 40 for sand. And we will then go to our soil texture triangle. So if you look at the soil texture triangle, I always tell my students to treat this like look at the y-axis, or what would be the y-axis. When I'm looking at this head on, the clay represents the y-axis because it's on the left. So we're going to draw a line straight across at the y-axis. Then what we're going to do is we're going to shift it. So the next one is the y-axis. So I'm going to show you what you would do. Let's just look at my slides. So I'm shifting it. Oh, look, I'm moving it over. So now the clay is no longer my y-axis, but now my sand is becoming the y-axis. So now, with the sand as the y-axis, the silt is the x-axis, what I'm going to do is look for the component for sand, or the percent for sand, and I had 40% for sand, so I draw an arrow across. So I have my original line for 20%, my new line for 40%, and we're going to do the same thing for the silt, and notice that's also 40. So where these all join, it is going to be in the loam. And loam is actually the best, it's the gold standard for agricultural soil. It allows, there's enough sand particles. The sand particles are big. They allow for more porosity and better permeability. But there's also enough clay particles that can hold back some of the water and can also attract some of these cations that are necessary. So we want some sand. We want some sand to allow for drainage. We also want some clay to allow to hold on to these ions to keep back some of that water. The silt kind of fills in the gaps, so to speak. But really, you're not really going to be questioned about how much silt you need. It's really about how much sand and how much clay. If too much water is going through, you need less sand, more clay. If too much water is being held back or not going through the soil, the water's just sitting on top, you got to add more sand because you want better porosity, better permeability. If you have water that is standing, the roots will not get oxygen because they will be submerged in water, and that can lead to bacterial or fungal outbreaks, and it can cause root damage and cause the overall death in the plant. When we're looking at soil fertility, we want to analyze a couple things. We want to look at the nutrients. We want to have these NPK, the nitrogen, the phosphorus, and the potassium, but we're also looking at magnesium, calcium, and sodium. So factors that are going to increase these nutrients, organic matter or humus, are going to increase the availability of these nutrients because they will be able to recycle them through the action of the decomposers. Looking at the soil texture can determine how much clay is present and how many of these nutrients are available. And finally, the soil pH will also be determining how readily these nutrients are available. So some factors that are going to decrease the nutrient availability is a low soil pH or a very acidic soil. Very acidic soil will not hold on to these positive ions. Very acidic soil will not be attracted because low soil pH means that there's going to be more H+ ions, which means they're going to take the spot. They're going to be held into the clay as opposed to these positive ions that we need. If we have excessive rain, it's going to wash away a lot of the nutrients. If we have unsustainable agriculture, we're going to just deplete the soil of these nutrients. And if we have erosion, that soil is washing away anyway. You're not going to have access to that soil. We also want water. We want to hold some water, but not too much. If we hold too much water in the soil, the roots become waterlogged and you will get root rot and the plants will die. So to increase water holding capacity, we will aerate the soil. You can do that by tilling the soil, digging it up. With tilling, there's a little bit of a drawback because you may interrupt some of the connections that have been made from different types of fungi under the soil surface or by roots that may be holding the soil in place. We can also increase organic matter because that organic matter will attract the water to it. Improve the soil texture by adding more clay, getting rid of some of the sand, adding more sand if it's too much water. You play around with that. Also, you can manipulate the root structure. You want roots to hold the soil in place, and the root structure is really going to impact how much water can be held. Some things that are going to decrease the water holding capacity: if the soil is compacted, you're not going to get as much water flowing through. You're not going to get as many roots pushing through that soil to hold onto that water. Erosion obviously takes everything away. The soil texture: if there's too much sand, the water will go right through the soil, not hold any soil, will be very dry. If there's too much clay, the soil will be waterlogged, and then the water cannot infiltrate into the soil. And if you lose roots entirely, there's nothing to hold that soil in place. So there are different tests that we can do to test soil. Some of them we will do in class, some of them we'll just learn about. Soil texture: this is one we will do, and we will determine the components and use the soil texture triangle. That's the one I modeled for you earlier. The permeability: you pour water through a soil sample and you'll measure how much time it takes to drain the soil, and you can determine which one has better porosity and permeability. If water goes through it faster, it is more permeable and has higher porosity. You can test the pH of the water to measure the H+ concentration. If you have acidic soil, you have more H+. Acidic soil, those H+ will be held onto the clay particles, which means they're not available to hold on to other nutrients, so that's a bad thing. You can test the soil color. Darker soil is going to have more humus, more organic material, which means it will have better water holding capacity. And finally, the nutrient levels. You will measure ammonium, potassium, or phosphates and nitrate levels. If you have more nutrients, you can lead to more soil or better crop growth, plant growth. And if you have low levels of this, it could indicate that the soil is acidic and therefore unable to hold on to these nutrients. So let's practice our FRQ writing. I want you to explain how the results of a soil quality test can be used by a farmer to increase their crop yield. So I look forward to seeing your responses. This was hopefully informative to you. I appreciate you listening to me talk about soils. I thank you for your attention, and I will see you soon.